In this lecture, we will talk about the transformer's main tank. The transformer's main tank is the robust central component of the transformer, serving it as the primary structural support. Constructed from the welded steel, it encloses and protects the core, windings, and insulating materials. Especially, it houses the majority of the transformer's internal component within a single enclosure. The materials used in the transformer's main tank can be categorized into two main groups: the tank body material and additional components. For the tank body, steel is the most widely used material, along with less commonly used aluminum and stainless steel for specific cases. Steel is the most commonly used material in the transformer tank due to its affordability, strength, and weldability. Low carbon steel is preferred for its good mechanical properties and ease of welding. The next aluminum that is used in the construction of main tank is aluminum. While less common than steel, aluminum tank offers several advantages including lighter weight and improved corrosion resistance and better heat dissipation. However, they are generally more expensive than the steel tanks. Stainless steel tanks, occasionally used for special applications or high corrosion resistance or non-magnetic properties, are required. However, its higher cost often limits its use. Additional components. There can be some additional components that are required in the construction of main tanks, and such as welding materials, which are electrodes or wire compatible with the chosen tank material, are used for welding the tank together. Gasket and seals. Well-resistant gasket and seals are used to ensure a leak-proof seal between the different tank components such as flanges and bushings. Paint or coating. Anti-corrosion paints or coating are often applied to the exterior of the tank for added protection, especially for outdoor application. Insulating materials. In some cases, additional insulating materials like foam or fiberglass may be used inside the tank for improved thermal performance. The specific materials used in the transformer main tank will depend on several factors, including size and the voltage of the transformer. Larger and higher voltage transformers typically require thicker and stronger tank materials. Application environment. For outdoor application, corrosion resistant materials like aluminum or stainless steel might be preferred. Cost consideration. Steel is generally the most cost effective options, while aluminum and stainless steel offer additional benefits at a higher cost. Let's explore the classification of the transformer main tanks. The classification can focus on different factors like material. In terms of material, transformer main tank can be constructed with the help of steel, stainless steel, aluminum, sometimes composite materials, which are aiming for lighter weight and improved insulation properties. Based on the construction, there are several types of transformers main tank, like welded steel tank. Welded steel tank are the most common type of construction for the transformer's main tank. They are fabricated by welding together steel plates to form sturdy enclosure. Welded steel tanks offer durability, strength, and ease of manufacturing. Bolted steel tank. Bolted steel tank are constructed by bolting together prefabricated steel panels. These tanks are assembled on site, making transportation easier for larger transformers. Bolted steel tank offers similar durability strength as the welded steel tanks but may require additional maintenance due to the bolted connection. Cast iron tank. The cast iron tank were historically used in the old transformers but have been largely replaced by steel tanks. Cast iron tanks are cast as a single piece, offering good strength and stability. However, they are heavier and more expensive to manufacture compared to steel tanks. Aluminum tanks are constructed from the aluminum sheets or cast aluminum components. They are lightweight and offer good corrosion resistance, making them suitable for specific application where the weight reduction and the corrosion protection are priorities. Stainless steel tanks are constructed from corrosion resistant stainless steel. They are used in specialized application where high corrosion resistance or non-magnetic properties are required. Cooling. Based on cooling, the main tank of the transformer can be classified into different types. First type is the well immersed or liquid filled tank. In well immersed transformers, the main tank is designed to hold transformer well, which serves as both insulating and cooling medium. The core and the windings are immersed in the transformer well, allowing the heat generated during the operation to be dissipated through the well to the tank walls and surrounding air. Well immersed tanks are commonly used in medium and high power transformers due to their efficient cooling capabilities. Dry type or air cooled tank. In the dry type transformer, the main tank is designed without the need for transformer well. The cooling is achieved through natural and forced air circulation around the core and the windings. The dry type tanks are often used in the application where environment concerns, fire safety, and maintenance considerations make these well immersed transformers impractical. Forced well cool tank. Some transformers use forced well cooling system to enhance the heat dissipation. The main tank is equipped with pumps and cooling fins or tubes to circulate the transformer well more efficiently, increasing the cooling capacity of the transformer. Forced well cooled transformers are typically used in large transformers or in applications where the higher cooling rates are required to handle the increased loads and ambient temperatures. Liquid immerse forced air cooled tank. In certain transformer designs, a combination of liquid immerse and forced air cooling system may be employed. The main tank contains the transformer well for insulation, while additional cooling is provided by circulating air through cooling ducts or fins installed within the tank. The hybrid cooling offers the benefits of both well immersed and air cooled transformer, providing efficient heat dissipation and insulation. Additional factors: sizing and capacity. Transformers come in various capacity with the tank design adapting to accommodate the specific needs. Application: different applications such as power, transmission, distribution might be specific requirement for the tank features like cooling system. Based on application, the transformer tank can be of three types: power transformer tank, distribution transformer tank, and specialty transformer tank. Power transformer tank designed for high voltage applications such as power dissipation and transmission system. These tanks are typically larger and capable of handling lighter power ratings. Distribution transformer tank due to use in low to medium voltage applications such as residential, commercial, power distribution. Distribution tanks are usually smaller and designed for lower power applications. Specialty transformer tank. Customized tanks are designed for specific applications such as instrument transformers, rectifier transformers, or traction transformers. These tanks may have unique features tailored to their specific requirements. Based on design feature, they are basically of two types: standard tank, which is the conventional tank designed with basic features and configuration, and specialty tank, customized tank designs incorporating specific features, additional reinforcement, enhanced cooling system, or special coatings for improved performance in specific environments. The transformer main tank serves as several crucial functions ensuring the safe and efficient operation of the transformer. First is housing and protection. The transformer main tank provides a sturdy and sealed enclosure for transformer core, windings, and insulating well. This protects these vital components from physical damage, dust, moisture, and other environmental hazards. Insulation. The transformer's tank walls and insulating well work together to electrically isolate the windings from the core and each other, and this prevents electrical breakdown and potential short circuit, ensuring the transformer safe operation. Cooling. Next function the transformer serves is cooling. The transformer generates heat during the operation due to the losses in the core and windings. The transformer's main tank plays a vital role in dissipating this heat. The tank walls conduct heat away from the internal components, and some tanks incorporate additional cooling features like the radiators which are attached to the tank walls. They increase the surface area for heat dissipation. Cooling fins, they are welded to the tank walls. They are further enhance the heat transfer. Forced air or circulation system used in the large transformers for efficient cooling. Containment. The main tank contains the insulating well which prevents leaking and spills that could pose environmental risk or safe hazards. Safety feature. The main tank often incorporates safety features like pressure relief valves, glucose relay, and grounding for preventing pressure buildup, detecting presence of gas, and also for preventing static voltage buildup and potential discharges. There are some essential components inside the main tank that are installed irrespective of application and voltage range. They are core, windings. There are basically three types of windings, which are primary winding, secondary winding, and tertiary winding, and transformer well and insulation materials. The auxiliary components. There are other auxiliary components that can be fitted inside the tank depending on their voltage and the nature of use, although some of those components are mostly installed outside the tank for high voltage applications. Bushings, it is placed on the top of the tank. The tap changers are placed on the secondary winding inside the transformer's main tank. The radiators are attached outside the transformer's main tank on two opposite sides. The glucose relay and the conservator tank, they are attached outside the transformer main tank with the help of a pipe connecting them to the tank. The pressure relief valves, they are placed on the top of the transformer's main tank. and the grounding system and explosion vent are also placed in the top of the transformer tank. There are some additional components like cooling fans that are employed in the last transformer for forced air circulation through radiators, especially in enclosed environments. This concludes our discussion for this lecture. In the event that you have any question regarding this presentation, feel free to post them in the comment section and don't forget to hit the subscribe button. See you in the next one.